Okay, well, why don't we go ahead and get started? Perhaps we have some other attendees joining along the way. So again, my name is Glenn Gray, Senior Solutions Architect with AppViewX. And today I'm going to be presenting on mapping the way to self-servicing and application delivery automation. A quick company overview of who AppViewX is. We have 7 locations worldwide. We have over 300 employees. We have a pretty extensive list of Fortune 500 companies that we do support with our product. And the primary focus of the AppViewX product is the leading low-code automation platform, which will enable NetOps and SecOps teams to support their increasing demands with greater agility. On today's agenda, I wanted to cover 3 basic topics, and then demonstrate 2 key solutions that are offered by the AppViewX platform in a brief demo, and then open up to questions and answers. So we'll start off with network management challenges, describe how the platform can provide self-servicing, and then cover some automation application delivery use cases. So currently, in the IT industry, in the IT community, the deployment of application instances, specifically web application instances, have to go through many, many stakeholders. And a lot of times there's a huge challenge in getting these individual stakeholders aligned, and then the sequence of tasks that need to be performed in order to create a web application pathway through the infrastructure can be very difficult. It can be time consuming, and just the overall perspective of the community that works together to create the application instance can view it such that, hey, the network is the bottleneck. You know, at this point, the ability to do hands-off compute turn-up solutions has been in practice for quite some time, but then aligning the infrastructure to feed into, to have traffic flowing into that compute resource often takes days, weeks, maybe a month or more. You're having to align the firewall security structure. You're having to potentially define routing and switching. You're certainly having to reserve IP addressing, DNS, fully qualified domain, A record, entries, and potentially the application delivery controllers or load balance infrastructure. And all of those individual components, those building blocks, are oftentimes supported by different business units. And those business units aren't always collaborating as effectively as possible. So what challenges are faced with that collaboration? Well, first of all, pointing out that cross-team collaboration. Are the dependencies that create the sequence or the building block structures for application delivery, are they coherently translated between each of the business units? You know, in my experience, just as a reference, in my experience, a lot of times one team did not communicate in the same terms with the same language as the other team. So you get into an iteration of trial and error. Well, I made a request for resources. However, my feedback was you didn't submit the request properly, or you did not provide me the detail that I need. And a lot of times the form structure is the limiting factor, where the form that's presented or the way in which the data is collected for the request is either vague or doesn't translate well into the understanding of the requestor. So what you end up with is a trial and error iteration of, I submitted, I got feedback that it wasn't what was necessary, so I tried again. And that went around and around until I finally got it right. Also, increasing workloads. Each one of these business units and contributors is certainly not sitting around waiting for the next request item to come through so that they can jump right on it and provide 100% satisfaction just for that iteration and then idly sit by waiting for another. No, they're handling 4, 5, 10, 20, 100 at a time, and there's quite frankly a constant overload of requests. The assembly line never does slow down or stop. Combined with that, flat or declining budgets. And this point of at this point in the maturation process and evolution process of the IT industry, it used to be, we have more work, let's find more people and apply it to the problem. Well, at this point, that's no longer a valid solution. You can no longer throw more people at the demand, because the demand is ever growing and will continue to grow over the next years and decades. Digital communications are a foundation of the way that the world communicates and functions on a daily basis. More and more transactions, more and more communications, more and more of our day-to-day operational necessities are fulfilled over the digital communication infrastructure. So the idea of throwing more people at the problem certainly can't scale and can't be a sustainable solution to the issue. So that aligns with flat and declining budgets. Leaders are identifying that we don't have budget to apply more human resources to the issue. We need to figure out more automation techniques and better ways of deploying application instances and managing the application delivery lifecycle in order to meet the demand while maintaining a flat or declining budget, i.e., making it profitable. The lack of application visibility, a lot of times the expansion of application infrastructure has expanded so quickly that there's a loss of that visibility, of that application-centric view of my application, web.1.mycompany.com, lives where and is in what state and status. So there's a long discovery cycle in order to look at the overall visibility in an application-centric view of how many resources are allocated to this particular application, how much traffic is flowing to them, what's their status, what's the health, do I have a valid failover scenario, is it highly available, and so forth. And then lastly, manual errors. As the contributors build out the application infrastructure, again, it's oftentimes multiple individuals, multiple business units, multiple organizations that are contributing to the application deployment cycles. And with that, a lack of overall standard practice. So what ends up happening is one segment of the application has been defined as such, another segment has been defined as another, and then a third has been defined as something yet different as well. So you have three snowflakes that are by nature should be of similar design, and each individual or each individual unit that has contributed to the application deployment or design concepts just provided or constructed it according to their own understanding, according to their own context, according to their own awareness. So it's very prone to manual error when you take that approach. So talking about self-servicing and automation, at AppViewX, we believe that is some of the key contributors or key factors to eliminating many of those challenges that I was just describing. So eliminating the reliance upon manual operations, that is one huge aspect, because if you have an alignment between how all contributors produce the application product, then you'll end up with much more consistent deployments and much more consistent performance of those deployments. Another bullet item, enterprises look at automation and self-servicing to achieve operational agility. That also speaks to the ability for application owners, those that support the application once it's in production or as it's going into production through its development and test life cycles, the ability to interact directly with that application instance to manipulate, change, adjust, maintain, whether it be software patching, updating, and so forth, the ability for that team to interact directly with those objects within the infrastructure greatly reduces the amount of time that goes into the care and feeding of the application instance and increases the agility of the overall enterprise. The practice of having to escalate normal maintenance, normal routine care and feeding of application instances to other entities just increases the overload, increases the time delay, increases the complexity of the maintenance of the administration process, because again, application owners perhaps do not utilize the same terms, language as network administrators and security ops administrators. So you have this lost in translation effect and leading to a trial and error. I wanted to adjust my traffic flows from data center 1 to data center 2, but because I did not communicate with the terms that are necessary for the understanding of network operations, it became a huge challenge. So with right automation in place, the IT ops teams can govern and monitor the state, health, performance of applications across multiple clouds, hybrid infrastructures, on-prem, off-prem. It extends the ability to maintain the application and only the specific application attributes or objects that are associated to it to those that administer the application. And that can be customized across all of the application instances. So reducing that manual process to a more agile and efficient process of, I see only my resources. The way that I view them is intuitive, easy to understand, and I can control that infrastructure. Some of those incumbent solutions and their limitations, I was just describing a bit. The necessity to require developer skill sets. So as we move towards automation, a lot of solutions demand that the interaction with the infrastructure, it demands that the administrators of that infrastructure start to ramp up and acquire more development skills, because they're having to utilize advanced coding mechanisms, whether that be a YAML construct, whether that be a Python interaction, perhaps even JSON, Java-based programming, or even some advanced shell techniques. The training that had been provided to many of the administrators of network infrastructure was not and had not been up to this point focused on developer skill sets and techniques. The task-based configuration management, that speaks to providing the specific tasks that are necessary for administering the application and not really having to understand the global concepts. It's easy to identify with, I have a application instance that is available in data center 1 and available in data center 2. I want to disable the service in data center 1 so that the traffic is migrated over to data center 2 so that I can perform maintenance on my data center 1 assets. Or maybe it's a pool construct. I have pools 1 and 2 in data center 1. I want to disable the members in pool 1 so that I can perform said maintenance and have the traffic flows to pool members in pool 2. All very task-based, easy to identify with, but yet the configuration management, if you were to want to extend the ability of application owners to reach into the infrastructure platforms to allow those basic tasks, there's a long and steep learning curve to figure out all of the nuances relative to that network operating system that controls the platform where those resources exist. So extracting that, removing that, having the ability to interact with the infrastructure in an intuitive, visually driven fashion that eliminates the complexities around multiple network operating systems, multiple technologies, and just focusing on a specific task-based configuration management. Enable, disable. Then there's the lack of cross-team collaboration. I've touched on this several times, and I refer to it often as that lost in translation effect. It's the language that is used within one organizational unit or one function of the overall IT community, and then how does that translate to the other business unit or function of the IT community. And a lot of times the terms, the language, the understanding is simply not there. It's just not intuitive. Developers don't necessarily speak in the terms of IP addressing, TCP, IP protocol structures related to port numbers, the understanding of UDP versus TCP, and then the security operations don't necessarily speak in the terms of routing, switching, and then the security operations and network operations teams don't often speak in the terms of the program structures, languages, code structures. So that cross collaboration can be made easier by allocating these visually intuitive interactions, the interfaces to interact, and application-centric views, and the task-based configuration management utilities to really eliminate that complexity of cross-collaboration and the time-consuming trial and error of submit request, feedback, try again, feedback, iteration cycles. And then as far as the difficulties to deploy, maintain, and consume, again, interacting with multi-vendor hybrid environments, there's a large complexity in deploying, maintaining, and consuming, because there's all of this knowledge base that must be in place first. And if it's not in a centralized administration group, then it's handed between individual SMEs, subject matter experts. And all of what I've been describing create this environment that is challenging, cumbersome, and difficult to navigate. So how can the AppViewX platform help to remediate a lot of these challenges I've been describing? Well, the low-code nature of the platform offers that intuitive, context-aware, visual workflow approach, to where it's abstracting the individual nuances of multiple network operating systems, multiple topology structures, multiple environments, on-prem, cloud, colo, etc., so that it makes it about how to orchestrate and automate the tasks rather than how do I individually complete this one task. Now that I've crafted that, I need to go on to engineering a way to apply the next task. And instead, it's made available for the alignment and task sequencing, i.e. task, object, workflow structure. So how do we do that? We have a large library of these pre-built tasks and a way to design easily customizable pre-built tasks that are specific to the needs of the enterprise. And then from that library, you can simply drag and drop and design a task objective sequence and begin utilizing that reproducible task objective sequence. And lastly, the platform is closed loop and state aware. Now what that means is it goes beyond the concept of just configuration management. So when it comes to the configuration management aspect, that's analyzing the configuration parameters of a particular appliance or infrastructure and simply saying, I have a template, does it match? And if not, go ahead and apply my template. Well, that doesn't really speak to the effectiveness or performance of the service. It just means that a template has been applied, not necessarily that it's working, that it's functioning as desired, or that it works within the overall design model or performance model of the application's needs. And what I mean by that is if you have a deployment scenario that has 3 instances, well, each instance is not going to have a mirrored image of the configuration. You may have iRule logic, you may have load balance algorithms, you may have security policy parameters that are unique to each instance. But within that closed loop state aware structure, you can identify that units 1, 2, and 3 of the application deployment instance are in these varying states. And I can validate with a performance monitoring tool. I can validate with a service that is running a test cycle. In other words, it's using replicated calls to the application instance to tell me if the actual database fetch for a test resource is actually successful. And so closing in those gaps of service validation, service state awareness can provide you with more accurate, more dependable automation and remediation techniques. So let's talk about one of the other critical components that we feel is a staple to increasing the overall agility when it comes to application delivery automation, and that would be the self-service component. Now, I touched several times on the complexity of navigating through the enterprise environment to do basic management functions, such as redirecting traffic, enabling, disabling, making minor changes to, say, a load balance algorithm, a time to live value on a DNS record entry, a migration of an application instance from on-prem to cloud. So things such as that. When you have the ability to isolate the objects that are associated with an application and then make those objects available for administration to the application owners or administrators, you're reducing the complexity, significantly reducing the complexity that it takes for maintaining the application-centric environment. You're also increasing the agility overall because there's the elimination of directing task-based requests between multiple contributors, multiple stakeholders, and those stakeholders are then freed up to perform the specifics that are necessary for them to maintain that infrastructure, design that infrastructure, improve that infrastructure, and not to the routine maintenance of basic functions such as adjusting time to live values on DNS or manipulating pool member enable disable states. And the AppViewX platform allows this self-service construct or this self-service architecture through a very easy and user-friendly structure or interface to identify what the role is or the user is, and then associating the individual functions they can perform and items that they can perform those functions on. So it's a fine-grained role-based access control architecture. And I'll be demonstrating this in just a short moment. And then going beyond that even, it's not just allocating these roles and attributes within a vacuum. It would integrate as well with external ITSM platforms where there's a construct of governance, a centralized location such as a ServiceNow or Remedy, to where all of this is tracked. And that then leads up to the decision makers and leadership members to be able to identify what's going on within the IT infrastructure in a centralized location. So for audit and reporting, the platform integrates with those enterprise resources so that there's the audit and governance practice applied and a trail so that leaders, decision makers can maintain a centralized control capability of what's going on within the environment. So here I have a couple of screenshots of creating that granular access control, which I'm also going to go into in a brief demo. But on the far left side, it's defining a particular user or a user group. And then you identify what provisioning workflows that that particular group might have access to. Once you've identified their workflow uh, details that they can utilize, you're then identifying which objects can they access and control. It'll make more sense when I get into the demo portion of it. So again, being visually intuitive, it's not a sequence of reading through file structures in text format and having to identify with key field values, assign variables to those key field values, associate those variables to another set of variables, and creating a whole relational database structure on your own. That's a very time-consuming, very complex process and requires a lot of skills, a tremendous amount of time to learn those particular skills and create that type of dynamic infrastructure or dynamic control system. The AppViewX platform allows for a very visually intuitive but powerful platform where once you're integrating with these enterprise components, you can very quickly, within a matter of a week or 2 weeks, begin to harness the automation tasks and workflow libraries within your existing infrastructure. And that means integrating with the platforms, i.e. ADCs, firewalls, DNS, IPAM solutions, info blocks, certificate authorities, ITSM platform, your identity and access management authentication resources like TACACS, Radius, LDAP, Active Directory, SAML. All of those can be integrated in a matter of a few days. And then with the built-in library of automation tasks, you can quickly begin to construct workflows. This is a depiction of the workflow design palette. I'm going to show a specific one in the demo portion of a zero-touch provisioning instance for an application deployment. It's going to integrate with notification mechanisms like email or Slack. It's going to integrate with IP address management resources for automated reservation of IP addressing, deployment of a virtual service templatized structure. This is an image that is showing you how the library construct works. On the left-hand side, you have the library components, and then each individual task that resides within a library. The one that's being shown there is the general, and it's showing you logic components of things like if, then, else, split, loop. So when it comes to features like loop, if you've designed something where you're deploying well, let's say in the world of certificate authorities, if you're wanting to renew certificates in bulk, you could identify that the start of the task loads the inventory of certificates, and let's say you have 2,000 of them, and 50 of them or 100 of them or 120 of them are pending expiry within 30 days. You want to take action on that. You could identify that I'm going to evaluate my full inventory of 2,000 certificates and then loop through each one of those to determine which are going to expire within 30 days. The ones that are not going to expire within 30 days bypass, but the ones that are, initiate this certificate renewal workflow process. That could then communicate with the CA to generate the CSR or utilize the existing CSR that's associated with that certificate. So you're just wanting to renew it. It would generate the renewal. It would then hand it back to the AppViewX platform to push to the device. So you're removing the responsibility, the need to interact directly with the private key, thus reducing your threat surface and aligning the CA issuing instance to the automation process and remediating these pending expiries with almost no human interaction, or with only human interaction of an approval process. So it does go to review for maybe the SecOps department, CISO, PKI administrators, but otherwise freeing up the complexity of exchanging private keys between application administrators to DevOps to NetOps to SecOps, and then reversing that chain sequence. So some of the salient features, which I've already pointed out, that workflow library, the intuitive and enhanced user experience, again, eliminating a lot of the need to learn how to code and to learn how to construct libraries of task workflows, task objectives, and the need to design from scratch how to integrate with all of these different network operating systems and vendor platforms and hybrid environments. The visual representation, it's a simple drag and drop canvas that you can design your workflows and thus enable that operational agility. You can define rule engines that are going to be event driven. So if the pending expiry reaches 10 days, the system is constantly identifying, constantly monitoring for the pending expiry. And as it approaches that date, it's going to take action once the rule-based engine event is identified that here we are 10 days prior to expiry. Let's begin the auto renewal process. That auto renewal process could be broken down into highly customized engine that might generate the CSR or use the existing CSR, submit to the CA, but prior to creating the certificate, there's an approval process. Once that approval process is completed, it can then move forward with the generation of the certificate, private key, and then push to the appliance. It could also be a rule generation that is based upon some performance level of the application instance, be it certain number of pool members or virtual service instance, or number of invalid requests detected by a IDS platform, or policy definition within the firewall structure. Again, some triggering based event occurs and thus violates a rule, so initiate an automation routine as a result. That plug and play integration, I was describing how quickly and efficiently you can deploy the platform by integrating with the network operating systems, the platform, the IT infrastructure itself, as well as enterprise resources like ITSM, IPAM, to very easily, when I say integrate, you're providing with a service account the ability to interact with that system. And then the inherent or the built-in workflow tasks of the platform instantly make available to you in the library the ability to create tickets, incident tickets, change tickets, request items, reserve IP addresses, reserve fully qualified domain names, generate A records, and so forth. And the reusability, once they're created, they're then highly reusable. They're highly repeatable. If you need to modify as things evolve, then you go back and you just modify the workflow construct that has been working previously to add in some new task sequence or requirement mechanism. But otherwise, once you've created it, it's reusable and you don't have to recreate the wheel each time. So comparisons, those manual methods versus the automation. In that manual method, again, the collaboration between hosting teams, ServiceNow, resource allocation, network teams, a lot of that is the trial and error. I have an understanding of what I'm wanting, but how do I communicate that to the other business unit? In my personal experience, which is very extensive in the way of working in enterprise environments, in the network operations environments, in the network design, and the security operations and security design elements, there had been a lot of that lost in translation effect. The ServiceNow catalog construct. When you look at the service catalog, it would provide a vague scope of give me a few details, maybe source destination, IP, port number. But as it relates to the platforms that you're deploying those on, there were so many items that were left out, so many items that were overlooked, but they were critical to the actual deployment. So once the form request got to the implementation team, it was, you haven't provided enough detail. So it gets kicked back with little or no explanation, just a reject. And so then it's a, well, I don't know what I didn't know, so let me try again. And then you try again, and you try again, and you try again, and lo and behold, you either have a success or you have an escalation process, which most oftentimes is the working routine. I go to my boss, they go to their boss, they go to the other team's boss, and then they work it back down. And that's the collaboration. It's work it up the flag over to another business unit, work it down, and then that process takes a week, 2 weeks for that communication cycle to be fulfilled, where it should be that it takes a matter of moments or hours to clearly communicate, these are my resource needs. Oh, I understand these resource needs. I can apply these resource needs. And then we move on to the next iteration of constructing the blocks that are necessary to have a fully functioning IT application resource. So that's where the automation and visual workflow construct of the AppViewX platform comes in. You're given an interface that has the difficult, complex tasks already built into each of the objects that are available within the library. So you're simply orienting the objects within the library rather than having to break down and define the fine details and nuance of what are the specifics that I need to communicate of this request that go into this network operating system versus the next network operating system versus the next network environment, cloud, on-prem, etc. It's already been developed. Therefore, the fixed input and variable parameter set is easy to understand, easy to plug in. The traditional service request goes in from the user as a request item. Network tickets are generated, goes over to network administration. Security tickets are generated, goes over to security administration. You go through the complex cycles of configuration. between that transition of the request and the configuration, again, there's this loop cycle, which occurs a lot of times. Your request was not detailed enough, the details that you provided weren't valid, et cetera, et cetera. So it goes around in a cycle. Wouldn't it be better to have an automation platform that's going to validate from the user's initial input, that's not a correct value, please correct it, or even offering up, these are the only correct values that you may select from, please make a selection. Really helps to eliminate that sequence of trial and error. So after you go through that configuration design of this is what I'm going to apply to the infrastructure, you would go through a final review, approval, and then into the implementation cycles. The drawbacks of this manual workflow process are that it's prone to that manual error. And the longer implementation cycles, because you're going through this trial and error sequence, and then the complexities of the silo structures where you're communicating requests to one silo, but not necessarily the same communication style, and not necessarily the same language that you're having to communicate with the other business unit and silo structure. So when it comes to applying the application delivery automation solutions within AppViewX, you're creating the service ticket, and then the engine, the rule engine, is identifying that you have or have not provided valid details within the request. Or again, like I said, you're offering up through the user request interface, these are the only valid and available services for the resources that you're requesting. Why? Because I'm integrated with the infrastructure. I'm constantly aware. I'm contextually aware. I know what's available. I know what is not available. And here is what you may choose from. You can choose data center 1 and cloud 2. And these are the IP address ranges within cloud 2. These are the IP address ranges within on-prem. And it doesn't even have to be IP address ranges. It could be a representational block of this is dev environment, and I will get you the next available IP address within dev environment. This is cloud environment. I will get you the next available IP address within cloud environment. So it's very intuitive and removes that barrier of having to have a broad knowledge base to your user base. Then once that request is actually validated, then it goes into the configuration generation. Then it can be escalated for final review, final approval, so that leadership, governance can be assured that only valid configurations, only valid requests are actually being implemented. And this reduces the whole complexity to a mere moments or hour of implementation cycles versus days, weeks, potentially a month, and of a highly error-prone workflow construct. So sample workflows, automation of virtual service creation. I'm going to touch on this in a zero-touch provisioning example, so I won't spend too much time on the slide. But you can generate this workflow request either through direct user interfacing with the web user interface of AppViewX, or an external service catalog construct of your preference. That could be a chef playbook. It could be a ServiceNow catalog, where the ServiceNow catalog is collecting the necessary attributes configuration definition parameters that are going to go into the infrastructure. So that could make an API call into the AppViewX platform. So you're using your ServiceNow catalog, and it's simply collecting what data set do you want it to put in, how do you want it to load balance, what protocol is it going to be listening on, the very minimal subset of configuration attributes that go into the deployment cycle. And then the automation engine extracts out the nuanced details that are specific to the infrastructure and applies them without the need for the end user. So in a typical deployment scenario, you're identifying with what resource you want to create, what application asset you're wanting to create. You could say, get the free IPs from your DDI infrastructure. You could integrate with ServiceNow to create the service ticket for archiving, for tracking of your IT asset inventories. You can then generate pre-validation. Hey, what is the state and status of the infrastructure before I deploy something, so that I can make sure that I'm not going to break something prior to implementing it. And then you can integrate approvals or not integrate approvals into that workflow. Hey, I want the SecOps team to approve this security firewall policy request. I want change management to identify or approve the actual ticket that has been created for the change, and if it's going to occur within the appropriate window, which I hadn't talked about scheduling, but through the rule engine, you can specify that a change would be deployed at a specific time and date, and it does not have to be live at the time of request. It can be deferred. And in that change approval, you can also have notifications for approval sent over to network operations in charge of load balance infrastructure, and system admins in charge of compute resources. So very aligning with the current change constraints, and not having to bypass any of the existing policy structure that the enterprise conforms to currently. And then once all of those pre-qualifications, pre-validations are met, you can then go into the change implementation. And then lastly, closing that loop, providing the post-validation. What was deployed? Is it all working, functioning, and operating as expected? Do I have a final performance validation so that I know what was deployed and implemented is actually working and available? So before we get into the question and answer, I'm going to jump over to a demo environment and just touch briefly on that zero-touch provisioning workflow that I was describing, just as an example of what it looks like, what it feels like, and then role-based access control. And then I'll open up briefly for question and answer as we're getting close to the top of the hour here. So I'm going to log into a demo instance, and I'm going to take us to the Visual Workflow Studio. Now, there's already a large catalog of pre-provisioned workflows that are generic in nature, but taking a look at this zero-touch build application, you'll see that from the library, I had selected items such as, in the form, draw that back over, I'm creating a form of what are the key field values that are going to be fed into this automation sequence in order to fulfill building an application instance. After I've defined that workflow in my form builder, which I can provide validation of, hey, for example, this is the port. Well, the only ports that are available are going to be the 65,534 open port instances. So I can't put in 1 million. That's just an example. In the case of an application name, if I wanted to say that this is a fully qualified domain name that must contain dot something, dot mycompany.com, then I could perform a pre-validation with a regex expression that's going to pre-check. I could also do a drop-down menu that says my domain is going to be widgets.mycompany.com or snarfs.mycompany.com. Again, all relative to whatever is necessary to customize the deployment of the application instance relative to your enterprise. So I'm doing pre-validations of what the user inputs so that they cannot put invalid parameters in, duplicate parameters, things like that. I'm going down to a fetch and reserve free IP. I'm going to a communication nested item, where in that nested item, I'm starting with, hey, I'm going to email one individual group. I'm also going to email another individual group, and I'm going to notify a Slack channel that this request has been initiated. Now that was the nested item. Once I've aligned this communication task, I'm then going down to a request for certificate, because this happens to be a zero-touch provisioning build application sequence for an HTTPS service. So now I'm taking the input that I had specified on the input form, which may have been some CSR parameters, and then I'm initiating a workflow task to initiate that request to, in this case, DigiCert. I'm specifying that here are the SSL details, which were passed from the previous input form, generating the CSR, submitting the CSR to the CA. I may have a delay there for approvals. I'm getting the certificate ID, I'm fetching the certificate, I'm pushing the certificate, and then I'm installing the certificate. I'm creating my virtual service instance. Again, another nested flow of integrating with the load balance infrastructure, the pre-validation, the post-validation, the build of the application, and that's the build of the context, the syntax that communicates with the appliance itself, the implementation of it, the post-validation, and then ending that sequence. I may then go back to a notification. Hey, your deployment has been completed. I'm notifying this email and this Slack channel. Then I'm closing the ticket with the ServiceNow incident. I'm getting my ticket identifier. I'm then marking it as closed. And then I'm doing a final notification out to stakeholders. Your tasks have been completed. Your ticket is closed. I validated that each of the components have been built as per the request specification. So again, this is how the visually intuitive workflow construct is designed and made, and it's made up of dragging and dropping the items onto and then specifying the unique details, such as this is the URL of the channel that I'm going to communicate with. So again, very intuitive, low code, does not require the programming skill set to know how to integrate with my my SMTP service, my Slack channel services, etc. Now, what does it look like from, this is the design view, what does it look like from a end user's perspective? I'm going to enable this particular workflow, and I've validated, it's going to validate the workflow engine first, and then I can go and utilize this from my request studio. So I go to that ZTP to try and find, hey, there's my build application. Now when I run it, these are the attributes that are from the form builder are taken in by the end user. This is just an example. It can be more or less detailed, but I'm specifying maybe a request item number that I've either generated, or I can have it generate from the automation design workflow to generate a new request item or change request ticket in my ServiceNow item. I'm specifying the LTM device, I'm specifying the application fully qualified domain name, service port listener, what persistence mechanism I want, what load balance mechanism I want, and then I'm defining the pool members that I'm going to associate, and then what my start and stop times are for my change management. I'd select next, and then it would implement, it would begin that workflow process. What it would look like after it's been completed, I'll just show you one that has been already submitted, requested, and closed. I'm looking for the zero touch application one. Well, I think this might suffice as well. Here I have a full chain, audit chain of what was performed. So in my input form, hey, here are the items that I submitted. I took that request item that was initiated in the service catalog. I took out the specific details, and then I initiated my change request through the ServiceNow instance. I fetched my IP. I gathered my SSL details, submitted my CSR. You'll see here the CSR REST response. And in it, I have, as it goes, it threads on there, but that's the cert and key. You'll see the detail there. I'll now install that cert. In this particular case, it was installed on a big IP device. You'll see the TMSH install syntax. That was constructed. Here's the config review. Now it also creates the pre-post validation and the rollback sequence. So if ever I need to revert back to, it's already been created. There's no, oh, I need to take what I designed and then reverse engineer it. It's already been reverse engineered. Once that's been approved, again, that's the config review, and that's why I see that little human element there. I put in my design workflow construct that I wanted a review step at this point. Is this what's going to go in? Yes, that's what I want. So then I approve, and it goes into the build application. I pre-validate. Is the environment in the state that I want it to be in before I implement this? Yes. So I'm going to go ahead and implement. Now I'm going to post-validate. Did I deploy what I wanted to deploy, and what's the status of that deployment? And in this case, it integrated. This is not the ZTP application one. This is one that had integrated with a Ansible playbook for a deployment, and then closes out that particular implementation. So we've gone a little bit past, so I just want to quickly show you what the role-based access control construct looks like. I described in great detail through the slide view. All of this can be allocated on a resource by resource or object by object basis to the individual stakeholders that are necessary. So how is that constructed? Well, first of all, within the parameter settings of the system, we define under the general what authentication mechanism we're using. So this is where I talked about integrating with the existing IAM structures. In this case, we have an LDAP instance. You can integrate with TACACS. You can integrate with Radius. You can integrate with SAML. So you're deferring off to your external resource as users log in through either web UI or API. Are they authenticated? Yes. Okay, now what are they authorized to do? Well, when you authenticate, the system, the external authentication system will return back attributes. Attributes such as within LDAP or Active Directory, this user is a member of NetOps, SecOps, DevOps, whatever the case may be. So then you're assigning whatever role they're associated with to their permissions. So in the case of, I have a DevOps user, I'm assigning them the name DevOps, and then I'm specifying which functions can they use. Well, I'm going to have them, the ability to request workflows. I'll allow them to roll them back, schedule them, view all of them, and let's say that that's it. Maybe they can use some other items out of the ADC, like dashboards. They could view some certificate inventories, etc. The point is you're customizing exactly what functions they'll have access to. So once you define that, and you would save it, you define the role and what functions they can perform. Now, what resources can they perform those functions on? Here you're simply designing, again, let's say DevOps. I'm going to allow you access to only workflows such as the ZTP. I'd search for it. You can use that one. Save it. And then out of those workflows, what portion of those workflows can you actually harness? Well, I can make a request for that workflow. I can roll it back, for example. So I've had something that I've deployed, and I also want to grant you the ability to roll it back because you know best the performance of your application. You've made a change to it. If you deem that it's not appropriate and you instantly want to roll it back without escalating and taking 2 hours to create a severity 1 incident, you would have the ability to do provisioning rollback. So I would associate that particular workflow in addition to the ability to create that workflow, because I gave you access control to the workflow, but you also have the ability to roll it back. You can't implement it because that's a responsibility of the other individual contributors, such as security operations, SecOps for the CA, and NetOps for the load balancing, but you can roll it back in an instance. So that's a brief description of how the role-based access control structure works and the workflow design palette works. I'd like to open up for any questions or comments at this point. And I'd invite you to utilize the chat feature of the Zoom meeting. So for anyone that would care to post one, please feel free. All right. Well, if there's no questions or comments, I want to thank everyone who's attended, and look forward to meeting with you in the community. Thank you, everyone.